So here's the demo for our web application. So for background context, the Texas Electric Grid manages power for over 26 million customers. And so given that, we want to have essentially accurate load forecasting to ensure grid reliability. So, kind of given this whole problem, the idea is that we wanted to create a centralized intelligent forecasting and analytics platform to help upkeep the infrastructure. And so, we'll go through this website and essentially show all the different filters, features, and then all the different graphs.
So our application is built using a fast API backend connected to a React frontend. And what you see here is our application. And our application consists of two different pages. We'll go through each component of each page. So the first component is the electricity hourly load by region. This is a very basic showcase of the different electricity load depending on the time. Here we have a filter for 2010 to 2011. And essentially, this first component will show the different load depending on the region of Texas. For our second component, we detect heat waves in the different zones of Texas. A heat wave is defined by a series of days, consecutive days that are all at a high temperature. And if that happens, we record it as a heat wave. And here we see that there are 7 heat waves during this time period in the north region of Texas.
On the bottom left, we show how electricity demand behaves on extreme heat days by combining our ERCOT load data with daily maximum temperatures. This helps us find out which regions are having the largest spikes during dangerous heat events, which is important for resource allocation and also reliability planning for the grid. And on the bottom right, we're showing the average load on dry versus rainy days, which is important because it highlights how different weather conditions influence electricity usage across regions.
Okay, so now moving on to the forecasting pane. So at the top left, you'll see that we have a date range, again from 2010 to 2011, which we can update. And so starting at the top left table, we have the historical versus forecasted load by region. And so the idea here is that we wanted to essentially forecast the electricity load by the different regions. Here you can see we used in the forecast configurations a statistical model like ARIMA, and then forecast it out. And again, going back to the top left, you can see the difference, especially just between the forecast and historical, given our training data. And so to see performance, we take a look at the top right graph that says forecast performance, and that shows our mean absolute percent error, R squared, mean squared error, mean absolute error for each of the different regions. And you can kind of see, essentially between all the different regions, how do they perform across all the different metrics. And then at the bottom left, we have the outlier detection. And so for all the different regions, you can essentially see, namely for the historical data, essentially all the days that would be marked outliers, whether it's above or below 3 standard deviations. And so this is kind of our two main pages that we use essentially to analyze and also forecast the data. From an optimization perspective, the first query that we really optimized was the comparing forecasted versus historical values and getting the metrics. And so before an optimization, it was 1 minute, 37 seconds. And then after it was 0.5 seconds. And we mainly just restructured the query. The next query we did was calculating the average peak load during each heat wave by zone. So that was 4 minutes and 15 seconds. And then after optimization, 0.8 seconds. Again, that was restructuring the query. Next, we did the get the mean load compared for rainy versus dry days by zone. And before is 30 seconds and after was 2.5 seconds. And then there we used caching. And then finally, the last query that we optimized was showing the allies for each month, in addition to the weather conditions. So before it was 3 minutes and 50 seconds, and then after is 35 seconds. And again, we use restructuring query. So in terms of optimization methods, the main one that we used was caching, so creating materialized views, and then also restructuring the query. So a lot of things that we did were creating filters beforehand, like in the where part, doing aggregation, so that way we only have to aggregate once rather than multiple times. And so given all this, we were able to create a pretty optimal SQL queries for at least most of them. And so this kind of just wraps up our whole demo. And yeah.